Okay, so we're going to do section 6.5, trig form of a complex number, where we have, our example is 3 minus 2i. Now to write the trig form, it's z equals the r times the cosine of theta plus I sine of theta. R is going to be the magnitude of z, and theta is the tan to the minus 1, or the inverse tan of our b over a. Okay? So now, let's find our r. Our a is our 3, b is the negative 2. I'm going to take the square root of 3 squared plus negative 2 squared. That's going to give me 9 plus 4, which is the square root of 13. Now, if it simplifies, you have to simplify it. Now let's find our tangent. Again, it's b over a, so that's going to be negative 2. So the tangent of theta is equal to negative 2 over 3. Do our inverse tangent. Because this is not on our unit circle, we're going to have to use our calculator. So if it's degrees, it's 33.6900. If we're in radians, it's about 0.5880 radians. Okay, now let's do our trig form. So z equals r, which is square root of 13 times the cosine of negative, oh, I forgot the negative over there, I'm sorry, negative 33.60900 plus I sine negative 33.6900. And that's our trig form. But there is a shorthand way of writing this, because if you notice, the angles will always be the same between the sine and the cosine. They're never going to be any different. So I can actually rewrite it as the square root of 13 CIS of my angle. Okay? And there's example 1. Okay, on to example 2. Same thing. We are going to get the trig form of this complex number. But I want to show you where this is at. So let's graph this. So negative 2 comma, or negative 2, negative 2 root 3 is going to be somewhere about right here. Okay? Where this is negative 2 and this is negative 2 root 3. Okay? So let's find our r. We're going to do the exact same things we did last time. We're going to find r, and then we're going to find our theta. Okay? So r is going to equal the magnitude, or the length of z. So that's going to be the square root of negative 2 squared plus negative 2 square root of 3 squared. Negative 2 squared is 4 plus negative 2 root 3 squared. So that's 2 squared plus root 3 squared, and that's going to be 12. So that gives us the square root of 16, which is 4. Now we need to find our theta. So the tangent of theta equals the b, which is negative 2 square root of 3 over negative 2. Oh, that's a bad 2. So that means the tangent of theta is equal to the square root of 3. Well, look what quadrant we're in. We're in the third quadrant. What's the angle for tangent equal to square root of 3 in the third quadrant? And that's 4 pi. That is really bad handwriting here. Over 3. So now let's write our trig form. So z is going to equal 4 times the cosine of 4 pi over 3 plus I sine of 4 pi over 3. Or we could rewrite it as 4 CIS 4 pi over 3. Again, both ways are acceptable. And that is example 2. On to example 3. Well, this time we're going to go from trig form back to standard form. So example 3 says that z equals 3 square root of 2 CIS of pi over 6. Well, the 3 root 2 is going to stay there. That CIS means I had the cosine of pi over 6 plus I sine of pi over 6. Basically, we're just going to expand this out and simplify it. That's all we're doing. Leave the 3 root 2 alone for right now. Cosine at pi over 6 is root 3 over 2. Plus, the sine at pi over 6 is 1/2. So this will be I times 1/2. Distribute the 3 root 2. So it gives me 3 the square root of 6 over 2 plus I, actually let's put the 3 in front. 3I root 2 over 2. And we could simplify it a little more because they both have the same denominator, so it's 3 square root of 6 plus 3I root 2 all over 2. Okay, so we've just taken a complex number from trig form and put it back into its original form. And let's do example 4. Same thing. Okay. Z is equal to 7 CIS of pi over 4. Same thing, I'm going to expand it out. Now you're probably thinking, okay, could I cut out some of these steps? Probably, but I like to take my time so I don't miss anything. Okay, well, cosine of pi over 4 is root 2 over 2. The sine at pi over 4 is also root 2 over 2. Distribute, I get 7 square root of 2 over 2 plus I did it again. 7I root 2 over 2, same denominator. 7 root 2 plus 7I root 2 all over 2. Okay, that's example 4. Okay, so now let's go on to example 5. And then 6, and then we're done with this section. Alright, so example 5. Wants us to do some operations. So I want to take the first complex number times the second complex number, and I want to take the first complex number divided by the second complex number. Alright, so our first complex number that we have, Z1, is 2 CIS of 2 pi over 3. And our second complex number is 8 CIS of 11 pi over 6. Alright, so let's do the multiplication one first. To multiply Z1 times Z2, you're going to take the R values for each and you're going to multiply them together. So R1 times R2 times the cosine sine of theta 1 plus theta 2. Alright? So let's go with this. So R1 is 2. R2 is 8. So I'm just basically plugging it in from our two complex numbers. And then the CIS of theta 1 is 2 pi over 3. Theta 2 is 11 pi over 6. Okay? Well, 2 times 8 is 16. CIS. Common denominator would be 6, so this becomes 4 pi over 6 plus 11 pi over 6. And that's going to be 16 times the CIS of 15 pi over 6. Well, I can reduce that, so I'm going to reduce it to be 16 CIS of 5 pi over 3. Oh, excuse me, 5 pi over 2. Alright, so that's our trig form. Okay, so if it wants you to leave it in trig form, you're done. However, let's take it back to standard form. Alright, so that means I would have 16 times the cosine of 5 pi over 2 plus I sine of 5 pi over 2. And that's 16 times the cosine of 5 pi over 2. If we look at it on our unit circle, so I'm going to make a little unit circle, a little graph over here. 5 pi over 2 is going all the way around and up here. Okay? Well, the cosine there is 0. Plus the sine at 5 pi over 2 is 1. So this just becomes 16 times I, or just 16I. Okay. So that is example 5. Let's move on to example 6. Nope, we can't move on to example 6 yet. I'm sorry, we forgot to do the division part. But again, this is our trig form, and this is standard. Okay? So let's do our division. Division is kind of the same thing. We're going to divide. So Z1 divided by Z2, and that's going to be R1 divided by R2. But this time for our CIS, instead of adding them, we're going to subtract them. So the theta of 1 minus theta of 2. Okay, R1 is 2, R2 is 8, CIS of 2 pi over 3 minus 11 pi over 6. Simplify it. So 1/4 CIS, common denominator again, so this is 4 pi over 6 minus 11 pi over 6. That's going to give me 1/4 CIS of negative 7 pi over 6. Okay. So again, this is our trig form. Let's do our standard form. So I'm going to take the 1/4 times the cosine of negative 7 pi over 6 plus I sine of negative 7 pi over 6. So again, let's look at our graph for our unit circle. Negative 7 pi over 6 is going to be over here. Our cosine is negative root 3 over 2 plus I times the sine of negative 7 pi over 6 is 1/2. Distribute, I get negative root 3 over 8 plus I over 8. And just kind of clean it up a little bit. So it's negative root 3 plus I over 8. And again, this is our standard form. Okay. Now let's move on to example 6. Alright, let's move on to example 6. Example 6 is de Moivre's theorem for taking a complex number to a root, or excuse me, not to a root, to a power. Now the thing to remember with this is that our complex number has to be in trig form. So this is for example 6. And de Moivre's theorem looks like this. It says if we have z equals r cosine of theta plus I sine of theta, z to any power is going to be r to that power times the cosine of n times theta. So that power times theta, not to. So if it's like a power is to the 5th power, you're just going to take it 5 times your angle, plus I sine of n times theta. Okay? So let's say we take the example we have right now, which is we have negative 1 plus I square root of 3 to the 19th power. First thing we want to do is we want to rewrite it back in trig form. Okay, so that tells me z is equal to I, excuse me, not I, negative 1 plus I square root of 3. All of that is to the 19th power. So remember to find trig form. We find r first, so let's find r. So that's going to be the square root of 1 squared plus, or excuse me, not 1 squared, negative 1 squared plus the square root of 3 squared. And that gives me the square root of 10. Or not. I'm sorry. I'm doing this very early in the morning, so I'm kind of tired. Negative 1 squared is 1. Square root of 3 squared is 3. So it actually is 4, so r equals 2. Now find our theta the same way. Tangent of theta is going to equal to b over a. And that is going to be the square root of 3 over negative 1, which is negative square root of 3. Now if we look about where our complex number was, our complex number was in the second quadrant because we had negative 1 and a positive. So our complex number's up here. And tangent is negative up here, but what value would tangent be? So theta has to be 2 pi over 3. Okay, so now we have everything we need to use de Moivre's theorem. And now it's just basically a plug and check. We're just going to plug the numbers in. So z to the nth is going to equal our r, which is 2, to the 19th power times cosine of 19 times 2 pi over 3 plus I sine 19 times 2 pi over 3. Let's kind of clean it up a little bit. And that's equal to 2 to the 19th times the cosine of 38 pi over 3 plus I sine 38 pi over 3. Now, if this is on your non-calculator section, don't try to multiply out 2 to the 19th. Just leave it that way. So this is if this is on your non-calculator. Okay, so no calculator, you do this. If you do have a calculator, all you're going to do is take 2 to the 19th. You're not going to multiply out the 38 pi over 3. And 2 to the 19th is, let me figure this out real quick. Alright, 524,288 cosine 38 pi over 3 plus I sine 38 pi over 3. And you could also rewrite this in the CIS notation. It doesn't matter. The shorthand notation or the long notation, it doesn't matter. And that goes the case for either one of our two answers here. So this is if we have a calculator. Alright. Okay, so that's de Moivre's theorem, and that's the end of this section. If you have any questions, make sure you bring them to class.